Okay, so the problem that I'm doing is an extension for number 10 on test number 3. So number 10 asks for the sum and product of the two other roots that are missing from the polynomial ax plus 2x to the fourth plus bx squared plus 10 equals 0. So the problem already gives you two roots, which is 2 and 5, and you have to find the sum and product of the other two roots. So for this problem, I got it wrong because after I reordered the terms, I didn't realize that there was no 0x, that the coefficient for x cubed would be 0, which is why I thought that the sum would actually be 0 for this particular problem, but I didn't catch that because I didn't realize that the coefficient for x cubed was 0 because I didn't include that as one of the missing terms. So the extension of that is this problem right here. So for this problem, it's a little bit different because it's a given polynomial and it gives you one root and you have to find the other two roots, but the method is still finding the sum and product of the problem. So the question asks for the other roots of this polynomial, 9x cubed plus 9x to the fourth plus 18x cubed plus 20x squared minus 32x minus 64 equals 0. And it gives you one x value, which is negative 1 plus rad 3i. The I is not included under the radical. So according to the conjugate root theorem, you know that all of these coefficients are real numbers, which is why if negative 1 plus rad 3i is a root, that means negative 1, this is the conjugate part, so it means that if negative 1 minus 3i must also be a root. See, this is the conjugate here. Okay, and then, so now that you know your two roots, and this polynomial is to the power of 4, so there should be 4 roots in total. Now that you know your two complex roots, the sum and product of these two roots, the sum being negative 2 and the product being 4. So then you go on to find the sum and product of all 4 roots, which is, so since the sum is negative b over a, it's negative 18, because this 18 right here is positive, so you make that negative. It's negative 18 over 9. 9 is your a. So then it's negative 18 over 9 is equal to negative 2, which is your sum of all 4 roots. And then for your product, you do the same thing, but it's the c term over the a term, which is negative 64, and you leave that as is, negative 64 over 9. So the product of all 4 roots is negative 64 over 9. Now, you know that your sum of your two roots are negative 2, and that your sum of all the roots are also negative 2. So you simply put that into an equation, because the sum of all 4 roots should be negative 2, and the sum of these two roots is also negative 2. So that means that R4, so that the third root and the fourth root can add up to be 0. The sum of the third and fourth root is 0. Now, doing the same with the product, you know that the product of R1 and R2 is 4, so you plug that into here. This R1 and R2 is equal to 4. So then your negative 64 over 9, which is your product of all 4 roots, negative 64 over 9 is the, product of all 4 of your roots are negative 64 over 9, and then you plug that into the equation, and you divide by 4 to find the product of R4 and R3, which is negative 64, which is negative 69, which is negative 16 over 9. So then you use the two sum and products of the missing roots that you find, and you put it into a quadratic equation, which is x squared minus 16 over 9. And this equation can be factored with difference of two squares, which is x minus 4 over 3 and x plus 4 over 3, which means that your missing two roots are negative 4 over 3 and 4 over 3. And now you found all 4 of your roots using the sum and product.